So we were just talking about layers. Now fossils are evidence of past life preserved in rock, and how are they going to be preserved? They're going to be buried by layer on top of layer. Here's a quick video.
Fossils are the remains or the marks of formerly living things. Most fossils form as part of sedimentary rock. This process begins when plant or animal remains are quickly buried in sediments, that is, the layers of mud or sand that settle out of water. After the remains are buried, mineral-rich water may seep down through the sediments and deposit its minerals in the remains. These minerals harden and strengthen the fossil. Over thousands of years, more and more sediment layers form on top of the layer containing the fossil. The weight of the upper layers presses down on the fossil-bearing sediment and eventually turns it into rock. In many regions of the Earth, earthquakes, glaciers, erosion, and other factors have exposed layers of sedimentary rock. Scientists often search for fossils in these areas.
There are several different ways that fossils can form, and I'll let you read about those in one of the attached articles on Moodle. But the most common way that dinosaur bones get to us, like that video just showed us, is something called replaced remains. So let's look at that in a little bit more detail. So on top here is a tree, 225 years old or so, and down here is a fossil. Which type? This is the replaced remains type, and this tree is a 225 million year old fallen tree, but it's not made out of wood anymore. What happened here is that this area that you're looking at in this picture, it got buried by sediments. Then mineral-rich waters came in and replaced every single cell of the wood with a little bit of mineral. And the exact shape of the original cells is the exact shape that's left behind. And then eventually, over millions of years more, that sediment got peeled away, and now we're back to being able to see the exact surface where these trees were. So if you look at the end of the tree that fell, that's 225 years old, you get to see all those wood cells. But if you look at the end of this fossilized petrified tree, petrified means turned into stone, and that is in fact what happened here. Every cell was replaced by hard minerals, and you look at it and you see rock. And those rocks used to be buried under thousands of feet of sediment here. So just a recap of the process: the tree fell, it got buried. As the tree decayed, water with lots of minerals flowed through it. Bit by bit, those hard minerals were replacing the cells where the tree used to be. And then, after millions of years, the tree got exposed again at the surface. And now most dinosaur bones are actually replaced remains fossil. They're actually made out of rock. So when you see a real dinosaur fossil that's in a museum, or when they are taking those out of the ground, what they're actually doing is they're taking out giant chunks of rock, and that's why they are so heavy, and why the movie How to Build a Dinosaur said it was so hard to mount these things. They needed all sorts of steel to hold them because they're much heavier than they were originally. They used to be made out of bone, relatively heavy. Now they're made out of hugely heavy rock. And just to show you that it's not just dinosaur bones, here's another video.
It takes a rare set of circumstances to turn a living creature into fossilized bone. In the case of Lucy, the famous hominid fossil, discovered in Ethiopia's Great Rift Valley in 1974, there is no evidence that she met a violent death. No predator or scavenger found her body before it began rotting in the lake's soft sediments. Her bones, which settled in the mud, may have been cracked or shattered by animals roaming around the shore. Heavy rains gradually washed in enough sand and gravel to bury her bones. These deposits built up over thousands of years, burying her remains hundreds of feet deep. The calcium in her bones, molecule by molecule, was replaced by minerals from these deposits, ultimately turning the bones to stone. She remained buried over millions of years, while the Earth's crust moved constantly, forcing the remains of her body closer to the surface. Heavy storms beating down on the Earth eroded the sediment, and most likely brought her once again to the Earth's surface. Her exposure made it possible for anthropologists to later discover her remains some 3 million years after her death.
So this starts to give you a picture of how rare it is for an organism to be preserved in the fossil record. When it dies, a whole bunch of things can happen to it. You saw that Lucy's bones were trampled by different creatures walking in the lake. Most of the time, those bones are getting destroyed. The soft tissues and the parts of our skin and things like that, they decompose. They are gone forever. The rest of it that gets covered quickly, that doesn't get destroyed, might get fossilized. But, of course, of those fossils, a whole bunch of them are going to be carried away and eroded, just like all the other rocks that we've talked about. Some of them are going to stay buried under thousands of feet of sediment, and only if we are very lucky will we get the exact snapshot in time that we need where we get to see things. So here is one of those amazing snapshots. This is two dinosaurs here. The headline is Velociraptor and Protoceratops in a fierce death grip. And you can't see it so well in the actual skeleton. This was on display in the American Museum of Natural History. But in this drawing, it's beautifully illustrated what you're actually seeing there. And now think about how rare it would be to capture this moment in time. How would that happen? One more quick video for you. This is an artist's reconstruction of the event. Here's Velociraptor. Its prey over here. They're about to fight. They're fighting. And then, just by chance, a landslide happens. And they get covered up and buried. In this case, that new layer was deposited very quickly in the landslide, not like our slow layers that we've seen in the previous video. So there are indeed several ways that fossils can form. Some of those rare glimpses into animal behavior like we just saw, we often call those trace fossils. And here is an example of a trace fossil. This geologist here has carefully peeled away all the layers on top of this layer that you're seeing. You're seeing the top of an ancient muddy beach. It was there for a few hours. It was wet. It hardened. It got buried over time by more sediment that came in, and it was preserved so that we actually get to see these dinosaurs walking here. For just a few hours of time, we get to see that short picture from maybe one afternoon when this was soft enough for them to be captured. And trace fossils, they give us the dinosaur footprints, but also we get to see these bite marks here. And the trace fossil in this case is, you can tell who ate whom by looking at the sizes of those bite marks in there. So the bone, or the bite marks, we call a trace fossil, but the bone is a replaced remains type fossil. So you're starting to see a little bit about how all these different fossils work together to help us see the evidence as we uncover and peel away different layers. So I hope you're starting to see how those layers can preserve ancient stories. And what we've been talking about so far is the accumulation of fossils in those stories. But the dinosaurs, of course, are no longer around. So how did they die? Well, that part of history is also going to be revealed in layers. And over the next few days, we're going to do a series of activities that are going to help us understand how the layers tell us a story about how the dinosaurs died off. So stay tuned.